Welcome back everybody to my YouTube channel. Today we're going to be talking about a topic that has baffled me for a while. I've been studying electricity for a while now, and they actually has never taught us how to use a multimeter. They just gave us a bunch of theoretical work that we have to do, and then eventually they just hope that wherever you work they'll teach you how to do that. So today I'm going to actually go through some of my meters. I'm going to show you the different kinds that I have from the McAfee, some of my flukes that I use, just show you how to actually use a digital multimeter and maybe show you some ways to test some components with these things. So those will help you out to troubleshoot and fix electronics, or maybe fix DB boards, or whatever you want to do for whatever that you guys use it for. Enough of that. So let's just jump in and dig deep and see dig deep and see how to use a multimeter and some of the functions. So let's go. Okay, this is a multimeter, digital. This is a standard digital multimeter that you probably come across with. As you can see, you have different symbols that are around your dial. You have your AC voltage, DC millivolts. Some multimeters might not have this millivolts, but you'll see when you use yours. You have ohms, continuity and diode test, AC current and DC current, and also how you connect it here would tell you in which ones would use this red one. You can use voltage, ohms, and continuity test. You can plug it in over here, but when you're testing your current, you got to know what current you're using to use it which in either side, but that's fine. So I got some components that I have got ready over here so that we can kind of test to see how some of these functions do work. So first of all, I'm going to start with continuity test, which I'm in over here. So continuity test tests between 2 points, right? If there's continuity. If there's continuity, your multimeter should beep. Like so. If mine's connected correctly. There we go. It should beep and have a 0. This is 100% continuity. It's beeping like this. Now, a cool thing about this multimeter is that it has a bar underneath here. This is something I think only flukes do, is that it has like a bar that kind of represents or kind of acts something like one of those analog meters that we had back in the day. If you see when there's like movement, it will move as like an analog dial that used to do back in the days. Really convenient when you're doing some measurements and you don't know what's wrong with something when you're troubleshooting, and you can see that the dial is flickering up and down like that. Would give you some kind of indication of what type of fault it is in there. But anyway, that is a side note. So our multimeter right now is just, that's pure continuity. So at the same time, we can measure diode tests. So what I have now is a diode. I have a 1N4, if I can remember, a 1N4007, which is a standard 100 volt diode. You find these in power supplies and rectifiers when you are converting AC to DC. But just to show you that you can test these components with your digital multimeter to see if it's faulty or not. So this is a working one. So if you connect the probes, I've connected it the wrong way, I gotta bias it correctly. If you connect the probes, you would see there is, it's my meter, I'm meter stuff up now. Okay, there we go. If you connect the probes, you should see a voltage drop of 0.5, 0.6, sometimes 0.7, depending on the semiconductor that you're using. And that is a good way to test this specific diode, or diodes in general, because it will have a voltage drop in one direction but should be open on the other direction. It's like a one-way check valve for electronics or for electricity. Current can only flow from this side, from the positive to the negative, and will not flow the other side. I'm not going to talk about Zener diodes or any other more specialized diodes like Schottkys and stuff like that. I'm just showing you quick and easy how to test this thing with your multimeter, or what can this thing test in continuity mode. This can also test transistors. I don't have any transistors on me right now. I left them all in my toolbox that I use, but it has the same principle as well. When you test between base emitter, base collector, you should get a voltage drop of 0.6, and you know your semiconductor is working fine. If there is any other problems with it, you would definitely see it where it will be like shorted, or it just won't open on any other side. But again, that's going to be a tutorial for another day where we go into deep diving on those components. Okay, so that's continuity and diode test. Now let's test resistance. Now resistance, or in ohms, is also a cool thing that or a great thing that you use for fault finding. It tells you how much resistance some things give. For instance, in motors, the resistance can change because of carbon buildup or abuse or whatever like that, and over the years it builds up and resistance changes. Some resistors can blow open, some can change resistance. There's a lot of things that can really go wrong with the resistors. So I got a couple of resistors over here. Let me get. Okay, I got a 47K ohm resistor. I'm not going to do the color codes today because, like I said, that's a whole other video or a whole other lesson for another day. So I'm just going to give you, or just show you quick how to measure it. If I believe 47 is, let me see this thing. Okay, so this is a 47K resistor, and again, super easy to test. You can even test this in circuit, where you just connect your probes to the one side and to the other side, and you should get a rough reading towards the same to that. Now, this has tolerance that's in the resistance that can change, usually by like 1%, 5%. I'm not really sure with this one, I didn't bother looking, but it's giving me run about the range of 47K, 46 point whatever. But we can safely say this is 47K ohm resistor. So resistance in circuits, you test them, you find if your fuses are blown open. You can use this to test it. You can test if your 100 ohm resistors are gone. Usually low ohm resistors are the ones that fall faulty or go open due to excessive current because they weren't built for that. This is a good way to just measure and test that and see if that is working. Okay, something that you wouldn't see so nicely with that multimeter is that you can measure things like capacitance. This is also another multimeter that I own. I own a lot of these. I used this in the beginning because I felt like this was more of a electronics multimeter, because it doesn't even waste your time measuring current, because we hardly ever do that. It gives you straight what mode am I in now? Even when you start to measure voltages, it gives you straight into voltages in DC. It doesn't even give you AC. You gotta change it to AC. And when you go to your continuity tester, diode test, it measures your ohms basically. So you only have these four things plus capacitance. Now, why I'm showing you this one, because the other one doesn't have a capacitor tester built inside. Before you pick out, you want to get a multimeter and stuff like that, read the specifications, because it will tell you in what ranges is these things accurate or not. This one over here is capacitance measurement is only accurate between 1 microfarad to 10,000 microfarads, which is a pretty decent range. Because the ones that normally go faulty are electrolytic caps, which are like this, that are in that range. So yes, I got this for that, and for a good year it has held me down until I got my other cap tester, or my LCR tester. But cool. So let's show you how to measure this. This is a fresh cap. Always discharge your capacitors. Don't discharge it the way I'm doing it. Have a dedicated discharger. I'll show you how to build one of those, but yeah. But this is fresh from my capacitors, my cap sets. This is I can't even see this thing. 220 microfarad cap at 50 volts. We're gonna put the negative probe on negative. Okay. And the positive probe on positive. And let's see what it tells us. I don't know if you can see. 220. 220. So this is measuring the actual capacitance. Now, this is not a reliable method of seeing if caps are faulty or not, because they can go leaky, they can go short. The ESR can definitely change in caps, especially caps that are very old or they've been worked on a lot with higher voltages than what they're rated for. The ESR can raise, and these don't measure, or in this mode doesn't measure that, because you can have a capacitor that has the correct capacitance but a higher ESR, which makes it useless in a circuit. You're going to have very weird faults with that. Sometimes the power supply won't switch on, or sometimes a lot of things can go wrong with these if the ESR is wrong, but just giving you some examples of that. Okay, cool. So let's move on to now voltage test and all that hoo-ha. Let's go. So right here in the front is just giving you some indication of signals of what's actually happening over here. So you have your live and you have your neutral coming in with your ground, and you have your output voltages. Don't be confused here. This is not a dual rail power supply. It's just one rail. If you measure it, you're only going to get one voltage out of here. So this is your AC input. It gets converted into DC, gets chopped up with your transformers and rectified and filtered and etc. And it comes out over here as 12 volts. So it's stepping down the voltage. So just to show you real quick, I'm going to measure, starting with live and neutral. We should be getting 220 volts. We get ours here a little bit hotter right now. I'm not really sure what's happening with the government, but it's really hitting us with a little bit of a high voltage. So we're getting actually 244 volts coming in, coming up from your live and your neutral. And that's if we put it in this squiggly line over here. This is AC. So if we put it in DC, we can then measure the DC voltage coming out. So just to make sure we don't get like a negative voltage by changing our ground reference, I'll put that in there. There we go. Then we get 12 volts or 12.72 volts coming out. If I want to, I could adjust it a little bit more with that pot, but I will not do that. I'm going to keep it as it is like that. So this was a repair that I did on this just to get the power supply up and running again. I would actually do more videos explaining how switch mode power supplies work and all that kind of goodies. So, but I'm going to end it over there just real quick, just a quick, dirty, easy way just to measure these stuff, and then we're going to actually get in there and more. Just let me know in the comment section that if you want me to do really deep videos where I actually go in here and step by step and show you how to measure things across the switch mode power supply, and on all, or you should have like more of classes, I suppose, where we could really get deep and dirty with electronics and really get into this, where this is, you know, something like that. But anyway, if you guys do enjoy this video like this, please do hit that like and subscribe button. Check out my other playlists that I have about this kind of stuff, and then I'm gonna check you guys at the next time. Peace.